Hi everyone, a very good morning to all. Now we are going to study about question number 95 that is related to transistor as an amplifier. So what is amplifier? See, transistor works as an amplifier in its active region. So in cutoff and saturation region, it will work as a switch, and in active region, it will work as a amplifier. So what is amplifier means? Amplifier means increasing amplitude of alternating voltage or current. So when an alternating input you have given, then amplitude gets increased. That process we call it as amplification. That device we call it as amplifier, and that is made up of transistor. Now here you need to understand what formulas are there based on which questions will come. When you consider the transistor, see here, so one is common emitter. Now here base and emitter and collector. Another one is common base. Here base, emitter, collector. Collector is output. Common emitter means base is input. And common base means emitter is input. Here it is input. And this is CE mode and this is CB mode. Now, in every such circuit, there is a current amplification factor. That means the ratio of output current by input current. Here output current is IC. By input current is IB. And here same way, the current amplification factor is output current IC by input current IE. So that is what we have to understand here, first thing. But this is DC current amplification factor. Similarly, there is change when you consider, that is AC. Same way here also, delta IC by delta IE. And similarly, we can also find out voltage gain. Voltage gain means voltage gain means output voltage by input voltage. So voltage gain means output voltage, that means output current into output resistance. Input voltage means input current into input resistance. But IC by IB is nothing but current amplification factor. Now into R0 by Ri. And here same thing, voltage gain will become current amplification factor, that is IC by IE into R0 by Ri. Similarly, power gain. Power gain means output power by input power. Output power means V0 and output current is IC by Vi into IB. That means again current amplification factor into voltage gain. Now that I can write it as current amplification factor into voltage gain means current amplification factor into R0 by Ri. So it will become square into R0 by Ri. Similarly here power gain will become current amplification factor whole square into R0 by Ri. So based on these formulas question will come. And one more thing is always in any mode IE equal to IB plus IC. So these are the equations related to amplification or amplifier. Let's see the example questions based on this, like how they can ask the questions. Now the very first question is, In NPN transistor circuit, the collector current is 10 milliampere. So IC is 10 milliampere. Okay. And 95% of the electrons emitted reach the collector. That means collector current is 95% of emitter current. Who will emit the electrons? Actually emitter. So that IC is 95 by 100 of IE. Then what is the base current? Now they are asking base current. IE equal to IB plus IC. Now base current IB equal to IE minus IC, where IE is 100 by 95 IC minus IC. So that 5 IC by 95 IC value they have given. So if you substitute and calculate, then you will get the IB base current value. So this way they can ask question based on IE equal to IB plus IC always. Now the next thing is the current gain for common base. Current gain for common base. Now remember that also common base means alpha. Alpha is current amplification factor, usual representation. Common emitter means beta. So that here they have given alpha value is 0.98. Now see, alpha is common base means IC by IE. Beta is common emitter means IC by IB. Now 1 by alpha equal to IE by IC, where IE I can write it as IB plus IC by IC. Then 1 by alpha will become IB by IC plus 1. So IB by IC is 1 by beta plus 1. So 1 by alpha equal to 1 by beta plus 1. So what is the relation will become? Beta will become 1 minus alpha by alpha. Sorry. The equation is, so from here 1 by beta equal to 1 by alpha minus 1. So alpha by 1 minus alpha, or else alpha equal to beta by 1 plus beta. This is the relation. Now alpha given means you can find beta. Find the current amplification factor if the transistor is used in common emitter. Common emitter means beta they are asking. So beta will become then 0.98 by 1 minus 0.98. So beta will become 0.98 by 0.02. So that it will become how much? 49. So that way they can ask the questions. Now next question, the current factor of a transistor in common base. Common base means alpha, that is again 0.98. Find the change in collector current. Delta IC is how much? Corresponding to a change of 5 milliampere in emitter current. Delta IE is 5 milliampere. Okay. What would be the change in base current? Delta IB. Now alpha means what? Common base. Common base means delta IC by delta IE. Now delta IE they have given. So delta IC equal to alpha delta IE. So alpha is 0.98 into delta IE is 5 into 10 power minus 3. That is delta IC. Now what would be the change in base current? Delta IB. Now beta equal to what? Delta IC by delta IB, common emitter. Now common emitter means delta IC by delta IB. Now we got delta IC. Now we have to find delta IB. So delta IB will become delta IC, already we found, by beta, where beta you can find from alpha. Beta equal to alpha by 1 minus alpha. So use these relations and you can find it. So whatever may be the question, you will use those equations whatever I have given. 3 equations for common base, 3 equations for common emitter. Now the next question, the current amplification factor for common emitter arrangement is, common emitter means beta, that is 59. If the emitter current 5 milliampere, find the value of collector current. See, beta means common emitter. So common emitter means IC by IB. From here first you will find, no, we cannot find from here. So first we have to take alpha. Alpha equal to beta by 1 plus beta. Then you will find alpha first. Then alpha equal to, that is common base, IC by IE. Now they are asking IC, so IC equal to alpha into IE. After finding alpha, you will multiply with IE. So this is how you have to calculate. You have to understand what data they have given, so that which equation can be used, you will come to know. Then you have to do the proper calculation. Now one last and final question. In an NPN transistor in common emitter mode, 10 power 10 electrons enter the emitter in 10 power minus 6 seconds. In an NPN transistor in common emitter mode, 10 power 10 electrons enter the emitter in 10 power minus 6 seconds. Only 2% of the electrons are lost in the base. That means first emitter current is 10 power 10 electrons means into 1.6 into 10 power minus 19. This is the total charge. In total time 10 power minus 6. This is the emitter current. Now base current is 2% of emitter current. So that collector current will become 98%. Now calculate the base current. Base current you can calculate. And the current amplification factor. Common emitter mode. Common emitter means beta, that is IC by IB. Now after finding IC R, directly you can find it. See here IC, IB both we got it. IC is 98 by 100 IE. By IB is 2 by 100 IE. So IE get cancelled. 100 get cancelled. Then beta will become how much? 49. So base current is 2 by 100 of IE. So first you find IE. Then if you substitute, you will get IB. Then here you will get beta. So this is how you have to solve the questions based on transistor as an amplifier. So completely formula based questions, but you have to get clarity on what is common emitter mode, what is common base mode, what is current gain, what is voltage gain, what is power gain, and what is the relation between alpha and beta, what is the relation between emitter, collector and base current. So that you can solve the question. You have to manipulate the equations. So between those things only. Now similar questions I have given as an assignment. Just try to solve all the questions, then you will get the idea. And in NCERT also they have given, see 5 questions are there. Try to solve those questions also, so that you will get the idea. So thank you all of you. We'll continue in the coming class with another question. Thank you.